Welcome to VKS Coding. So in this video, we'll check how to scale the database, because when we need to scale the database, suppose you are dealing with a single database and your requirement changes and now you have to store the more data into the database and that database will not be able to handle it. So in those scenario, we have to scale our database. So to scale the database, we have a two option. First one is a vertical scaling and the second one is the horizontal scaling. So basically in the vertical scaling, we increase the CPU, RAM and the disk size of the machine, and in the horizontal scaling we add a more servers, and based on the data how we store in these machines we further divided into the horizontal scaling into the vertical sorting and the horizontal sorting. So these are the two types of scaling we can do. First one is the vertical scaling and second one is the horizontal scaling. And the way we add the data into the horizontal scaled machines, that is further divided into vertical sorting and horizontal sorting. So now let's check one example. Suppose we have one table here and that is having the student information, student ID, name, roll number and the branch. And if you wanted to vertical scale this particular database which is having this table, so what we do, we keep this table as it is in the same machine and we increase the machine size by increasing the RAM, CPU and the disk. So the table will not change when we do the vertical scaling. Now let's see in another approach when we do a horizontal scaling, and in the horizontal scaling the first type will be the horizontal sorting. So suppose we have one table here and it is having the 6 rows, then we shard into the basically shard 1 and shard 2. It's kind of a two machines where we keep the one table data in by dividing into the two tables and we keep both of them in separately. So we take a first 3 row and store into the shard 1, and we'll take next 3 row and store into the shard 2. So how we decide which rows goes into the which shard? So basically we have to pick up the partition key to distribute the data into the shard. So partition key nothing, it will be a unique identifier. Suppose we have a student ID table, then student ID will be having the ranges of 1 to 100. Then what we can do, from 1 to 50 will go to the shard 1, and from 51 to 100 it will go to the shard 2. So in the here if we divide the student detail into the two different shard via horizontal sharding. So in the first shard will contain the information about the student will be from row 1 to 50, and the second shard will contain the information about from 51 to 100. So this is how we do sharding in a horizontal scaling for horizontal sharding, and it is basically a range based sharding. This range will be going to the shard 1, this can be a range 1, and this range will be go to the shard 2, and this is how it is divided into the horizontal sharding. And the next we have is a vertical sharding, second type of a horizontal scaling. So basically suppose we have a table, and in that table it is having a 6 column, then it will be divided by a column base. So first 3 column will be going to the shard 1 and next 3 column will be going into the shard 2. So this is how in the vertical sharding the column wise it is divided. So it is divided by a column wise. So this is how the tables are further divided in the vertical scaling and the horizontal scaling. So now let's see one example of scaling the database via vertical or horizontal. So we have initially one table in the database, and now this table we wanted to scale it via vertical scaling. The same table will go into the machine, and this machine can be increased by a RAM, CPU, and the disk size. And the same table schema will be go to in this machine. So there will be no change in the schema, but there will be always a limit for vertical scaling, because after certain point of time we can't increase the RAM and CPU, and bigger machines are also expensive as well. When we wanted to scale via horizontal scaling this table, so basically here we need to add a more machines. And when we do a horizontal sorting, so basically it's kind of a row wise sorting. So here if you see the product information having the 4 details, so two will go into the shard 1 and the another two will be going to the shard 2. So that's how I have given the example here. So in next type in horizontal scaling we have a vertical sorting. So in vertical sorting we have a two shard 1 and shard 2. So in shard 1 these two column will go together with the product ID column, and in shard 2 another two column will be go together with the product ID column. It is used enhancing the query, and if you want to apply the extra security on the particular set of data, so we can easily apply that security in the particular set of data. So this is all about the vertical sorting. So this is all about vertical scaling and the horizontal scaling. In vertical scaling we have a limit, we cannot increase increase after certain point of time, but in horizontal scaling we can increase the as many we want by adding a more servers. So now we have seen the limitation of vertical scaling. We cannot increase after once the machine size become a bigger and we have a capped on RAM and CPU size. So let's see what is the problem in the horizontal scaling. Suppose we are using the horizontal sorting, and these three sorts, first sort is containing the value ranges from A to P when we are storing the names of a user, and second sort is containing the information from Q to T, and the third sort is containing the information from U to Z, and the first sort is getting the lot of data coming in this sort. So this sort is becoming full. Then after that we have to reshard further this A to P first sort. Then again what is happening, this A to D sort is again becoming a full. Then we have to further reshard this A to D. Then it's kind of a becoming a tree like structure, right? So every time the sorts is becoming full and we have to reshard it. So how to handle this situation? So we have to basically distribute the data evenly. To overcome this problem, we have to use a consistent hashing. So I have discussed consistent hashing in a great detail in the next video. Please watch that. You will get to know about consistent hashing. So now next problem we have in the horizontal sorting is like when we store the data, basically that is kind of a normalized data. So here I have given one example. Suppose it's having a student table, student ID, name, roll number. It is having a department ID, and that department detail is having in a different table itself, and that could reside on a different database itself. Suppose if somebody want to query and get the student information with the department details, then that time we have to join this to DB and we have to query it. So that is kind of very expensive, right? So how we can optimize this? We can optimize doing by denormalization. So what is denormalization? It's basically whatever the this department ID is referring to the another table, we keep those information to one table itself, and we can store that information in the single DB itself. So we can query this DB and we can get the detail. So that's how we can enhance the query and we can solve our problem. So this is all about scaling the database. So please do subscribe my channel to get to know more about the system design topics.